Hello and welcome to section 6. In this section, we are going to take a look at Internet of Things or IoT, app tethering, Bluetooth LE, and Wi-Fi connected applications. In this lesson, we are going to take a look at Internet of Things. What is the Internet of Things? The Internet of Things is the network of physical devices, vehicles, home appliances, and other items embedded with electronics, software, sensors, actuators, and a connectivity which enables these objects to connect and exchange data. Each thing is uniquely identifiable through its embedded computing system, but is able to interoperate within the existing Internet infrastructure. The IoT allows objects to be sensed or controlled remotely across existing network infrastructure, creating opportunities for more direct integration of the physical world into computer-based systems, and resulting in improved efficiency, accuracy, and economic benefit in addition to reduced human intervention. When IoT is augmented with sensors and actuators, technology becomes an instance of the more general class of cyber-physical systems, which also encompasses technologies such as smart grids, virtual power plants, smart homes, intelligent transportation, and smart cities. In the IoT sense, can refer to a wide variety of devices such as heart monitoring implants, biochip transponders on farm animals, cameras streaming live feeds of wild animals in coastal waters, automobiles with the built-in sensors, DNA analysis devices for environmental monitoring. Legal scholars suggest regarding things as an inextricable mixture of hardware, software, data, and service. These devices collect useful data with the help of the various existing technologies and then autonomously flow the data between other devices. Why IoT security is not there yet? The IoT security is difficult to implement due to amount of factors to address. IoT backends require the same security as any web system, but we also need to care about the physical security of devices and security of networks they are connected to. However, the technical challenges are generally not hard to solve. IoT specific challenges. Just like web or mobile applications, software running in physical devices. However, there are additional challenges for IoT. First, current architectures often treat devices as dumb terminals with little to no configurability built in. Accompanying mobile apps might help there, but only if they allow configuration of data sharing along with the modes of operation. So capabilities required for consensual IoT. Obviously, we need the technical solutions for specific security issues, but we might only be fighting fires if we don't grow the capabilities required to develop secure and reliable IoT systems. Configurability. This could fall under operability below, but configurability is so crucial for consensual IoT that we need to single it out. Often, IoT devices need to send data over the network to fulfill a goal, but that doesn't equal a wildcard for all data collected by the device to be sent over at any time. Testability. Testing the software in the device in isolation, and it's important, but testability for IoT systems means we can also reproduce the ecosystem around the device and how users and other systems interact with it. Realizability. So it's not enough to identify and diagnose incidents. We also need to be able to take swift actions. Often, fixing the problem requires a change in the software running on the device. It might be one-line change as in the energy meter example. Stop sending the location data, or it could be a more complex change requiring backend notifications. Imagine that the energy provider was tracking the customer's consumption based on meter location, not on a customer ID. Regardless of change the size, being able to deploy frequently, quickly, and reliably is fundamental for IoT, either to fix a problem or to provide more control to users over their data and device interactions. Modern mobile and web systems rely on continuous delivery techniques, such as deployment pipelines or canary releases, to test changes at multiple stages, from source control to a subset of instances running in production to a full rollout to the entire live environment. If a change fails to produce the expected results in production, it should be straightforward just to deploy the previous good version from an artifact repository. Strengths and weaknesses of IoT communication patterns. The IoT world is all about communication between devices, gateways, and the cloud. The messages are exchanged between all of these parties in order to provide a comprehensive end-to-end solution. It's common to consider the following as the main communication patterns, which are different in terms of how messages flow between parties and the objectives they have. Telemetry. The telemetry means data flows in one direction from the device to other system for conveying status changes in the device itself. Inquiries. And that means requests from the device looking to gather required information or asking to initiate activities. Commands. Commands from the other systems sent to a device or a group of devices to perform the specific activities expecting a result from the command execution, or at least a status for that. Notifications. Notifications, its information flows in one direction from the other systems to a device or a group of devices for conveying status changes. IoT is more about messaging, exchanging data which already defines its own patterns, like competing consumers, requesting, replying, and so on. And the protocols provide such patterns in different ways, natively or not. I hope you have acquired about what Internet of Things is. In the coming video tutorial, we will learn Delphi for Internet of Things. So, see you in the next video.